Hello friends, so in this video we're going to be studying rationalization and division of surds. We're going to be looking at more examples on that. In the previous video we looked at the conjugates of surds and the introductory aspect to rationalization and division of surds. In this video we're going to be talking more on the rationalization and division of surds. Now suppose we are given as our first question 8 minus the root now of 6 divided by root 3 plus now root 2 plus root 2. Very true. Now how do we evaluate this question, right? So like we said before, we use the conjugate of the denominator, this denominator here, to multiply both the numerator and the denominator, right? So what happens is this surd at denominator, we use the conjugate, and we explained what conjugates are in the previous video. They are the same surds with different signs, right? So here the conjugate will be root 3 minus root 2. It's the same surd, it's the same compound surd, it's the same compound surd, but the signs are different now. Here we also multiply by the conjugate of our denominator. So we have root 3 here minus root 2. Now we FOIL out at the numerator there, right? So 8 multiplies root 3 and 8 also multiplies minus root 2. So 8 times root 3 gives us 8 root 3. 8 times minus root 2 gives us minus 8 root 2. Minus 8 root 2. Now in case you don't understand what we are doing and how it is we are doing, please check out the previous videos on surds before moving right straight to this video, right? Very true. Now I will leave a link for that in the description box below. Now the negative root 6 now multiplies root 3 and multiplies minus root 2 in this bracket. We have minus root 6 multiplied by root 3, so that will give us minus root 18. So because both of them have roots, we can multiply the numbers within those roots, right? So minus root 6 multiplied by minus root 2, that gives us plus root 12. How true, how true. Now at the denominator, I said in the previous video that what happens there is a difference of 2 square, right? Such that what we have there is, suppose we are given a plus b multiplied by a minus b. Rather than opening these brackets, what we can simply do is do the difference of 2 squares there, right? So we have a square minus b square. This is what you're going to get when you eventually open the bracket. Our final answer will always be the square of the first letter or number and minus the square of the second number. How true, very true. So this gives us at the denominator now root 3 square, root 3 square minus root 2 squared. So notice now this square cancels the square root and this square cancels this square root, right? Beautiful. Now at the numerator now we can simplify further, right? So this gives us 8 root 3 minus 8 root 2. This is the part we are going to have to simplify. Minus now root 18. Now two numbers whose product gives us 18 are 9 and 2. So we can go ahead and write root 18 as root 9 times 2 plus two numbers whose product gives us 12 now, and one of them must be a perfect square, are 4 and 3. So this gives us the root of 4 times 3. How true, how true. So at the denominator now we have the root of 3 has been cancelled out and the root of 2 has been cancelled out, right? So we are left with 3 minus 2. How true, how true. So you know that gives us 1, right? Very true. So this would give us, now 8 root 3 remains 8 root 3, then minus 8 root 2. Let's write it the exact same way it is for now, root 2. Now we have minus the root of 9 times 2, right? So the root of 9 there gives us 3. So we have minus 3. The root of 2 now gives us an irrational number, right? So we leave it the exact same way it is. Now, here we have plus. The root of 4 gives us 2 times root 3. And since root 3 is an irrational number, we leave it the exact same way it is. How true, how true. Now, at the denominator there, notice now that we have the 1 there, right? We have 1 at the denominator. So we may not necessarily need to write the denominator anymore, because what we have there would be our numerator all over 1, and it will still give us the very same thing, right? So here now, let's simplify this numerator further. This gives us 8 root 3. Now we are attempting to collect like terms, right? So what we do now, we are going to put all the numbers having root 3 together and all the numbers having root 2 together. So 8 root 3, and we're going to have plus 2 root 3, plus 2 root 3, minus 8 root 2, minus 8 root 2, minus 3 root 2. How true, very true. So 8 root 3 plus 2 root 3, right? That will give us 10 root 3. 10 root 3. Minus 8 root 2 minus 3 root 2 gives us minus 11 root 2. How true, very true. This would be our final answer. Let's look at one more example. Here's another question that we could evaluate, and we are told to leave our answer in the form a root b minus c. Now, let's solve this question. So we have 5 root 2, 5 root 2 plus the root of 3 plus the root of 3 divided by root 3 plus root 2. Now we multiply both numerator and denominator by the conjugate of the denominator, right? So the conjugate here gives us the root of 3 minus the root of 2. How true. Here we also have the same thing. The denominator's conjugate now multiplies the numerator also. So this would be root 3 minus root 2, multiplying both the denominator and the numerator. Now let's open this bracket. So this gives us 5 root 6. Now 5 root 2 multiplied by minus root 2, this gives us minus 5 root 4. Also, we're going to use positive root 3 to multiply root 3 minus root 2. So here we have plus the root of 9 minus root 6. How true. At the denominator now, recall that we said that we're going to have a difference of 2 squared there, right? So that gives us the root of 3 all squared minus the root of 2 all squared. So this square cancels this square root, and this square cancels this square root, right? How true. Such that in the aftermath, we're going to have 5 root 6 now minus 5 times the root of 4 gives us 2 plus the root of 9 gives us 3 minus root 6. The root of 6 gives us an irrational number, so we leave it the exact same way it is. So at denominator now we have 3 minus 2, right? So this is 3 minus 2, and that will give us 1. That will give us 1. Such that in working with this now, we're going to have 5 root 6 now minus 10, because 5 times 2 gives us 10, plus 3 minus root 6. How true. Now at denominator we're going to have 1. 3 minus 2 gives us 1, so we leave it the exact same way it is. So let's just omit that at the denominator now, and we can have this gives us, now we're going to collect like terms now. We're going to have 5 root 6 minus root 6 minus root 6 minus 10 plus 3 gives us minus 7. How true. Now, this gives us our final answer to be 5 root 6 minus root 6 gives us 4 root 6 minus 7. So notice now that our answer has taken the form. There's A root B minus C. So this is what we're told to leave our answer. So this would be our final answer. How true, how true, very true. Also, we could be asked to evaluate 6 root 2 plus 4 root 3 all over 8 root 2. How do we evaluate this? Since we don't have a compound surd at the denominator, a compound surd such as 8 root 2 minus 4 root 3 or 8 root 2 plus 4 root 6. Now, in doing this, we must multiply both the numerator and the denominator by whatever root we have at the denominator. In this case, our root at the denominator would be root 2. So this gives us 6 now, root 2. 6 root 2 plus 4 root 3 multiplied by root 2. At the denominator now we have 8 root 2 multiplied by root 2. So in the aftermath, right, this gives us 6 root 2 multiplied by root 2 gives us 6 root 4. 6 root 4. Now, plus 4 root 3 multiplied by root 2 gives us plus 4 root 6. So the roots multiply themselves. Such that at the denominator now we have 8 root 2 multiplied by root 2 gives us 8 root 4. 8 root 4. How true. So in doing this now we have 6 root 4 gives us 2. So 6 times 2 plus 4 root 6. Root 6 now we write it the exact same way it is. Why? Because it's not root 6 now, it's not a perfect square, right? How true. At the denominator now we have 8 times the root of 4 gives us 2. So 8 times 2. Right? Very true. So we can cancel out directly from here, right? So 2 here, 1. 2 here, 1. 4 here, 1. 4 here, 2. 2 into 2, 1. 2 into 6, 3. So in the aftermath, we are left with 3 plus root 6. How true. Very true, very true. Notice now that we can't add this up, right? Because these 3 and root 6 now, they are not the same. We can't add 3 to root 6. And as such, this will be our final answer. Thank you so much for watching. Now, I'm going to leave some questions for you to solve at the end of the video, right? So put your answers in the comment section. In the next video, we're going to be talking about radical equations. See you in the